Welcome to today's technical corner at MTD CNC. As you can see, we're not directly in the studio, but we're a bit satellite today. But I'm joined with Lee Scott from Starrag UK. How you doing, Lee? You all right?
Very well, Mark. How are you?
Yeah, busy times. You know, trying to communicate in different ways. Hence why we're doing what we're doing today. But I want to go straight into it. Is that you know, I've been very lucky to travel around most of your, or barring one factory, and it's incredible the portfolio of different products that you have. But one key area in the UK, but obviously worldwide as well, is aerospace. And what I wanted to talk to you today about is aerostructure and aluminium structured parts. When you look at one of your, quickest machines that I've seen is the Ecospeed machines. They are seriously fast. Removal rate of aluminium is fantastic, and I've seen that at one of your customers, Magellan. But yet you say you've improved it further. How can you do that?
We've made it more powerful. It's more dynamic. We've added new Industry 4 functions, and we've also added new models into the range.
So when you say you've introduced new models, are you saying that you're developing, or when are the first machines actually hitting the market?
Well, the first machines hit the market. They were introduced to the market over 20 years ago, and they're all still in operation, which is really impressive when you consider how hard these machines work. And since then, there've been various upgrades.
And when you look at the removal rate, it's some 30,000 RPM. But so do the others?
Yeah, other companies run at those kind of speeds. But what we've done is we've really analysed where the sweet spots are for high performance cutting. And we ensure that we have exactly the right power at exactly the right speeds. So we don't have a straight line power curve from 0 to 30,000 revs. We have maximum revs at a much slower speed that then continues to 30,000. So we can bury a 50mm cutter when roughing at optimized speeds where we have full power and competitors don't. So for example, a competitor's 80 kilowatt spindle might achieve 5.8 litres of swarf, but we will achieve 12 litres per minute of swarf with our 150 kilowatt new spindle. So that's 150 litres of swarf, or a large oil barrel of swarf filled every minute. So productivity is what counts for our customers, but it's not just about the spindle.
No, it's interesting actually when you say about the amount of swarf. When we was at Magellan's, I mean, obviously they had to get rid of this in blocks. You know, the machine was cutting at some amazing speeds with. Obviously, the swarf is your enemy sometimes, but the product that you had there absolutely worked for them, very bespoke. Now you talk about spindles. Now the spindles mounted in a parallel kinematics head. And I learned a little bit this when we went to your factories. Tell us a little bit more about it.
Well, this is what we call the Sprint Z3 head, and you're absolutely right, Mark. It's a parallel kinematic unit where you've got 3 linear axes that can each accelerate at 1g. So when you move all 3 together, you get a z-axis. But when you move them independently, you can effectively move the tool in a 5-axis movement extremely quickly. So competitors generally have 2 rotary axes, and to go around a 5-axis corner in an aircraft part, you're always running 1 rotary axis much faster than the other, and one's always trying to catch up with the other. We don't have that problem.
So with the additional power, have you made any changes to the dynamics, Lee?
Yes, as the cutting process improves, so does the speed that the rest of the machine has to work at. And sometimes we're moving really large billets on these machines, and we need to move them very quickly. So we've re-engineered the drive chain that controls the speed of the table movement, and that subsequently increased the feed rates and the acceleration by over 20%. And this, combined with the extremely high acceleration and jerk settings on the machine, means that we can move the tool around really complex angular walls and pockets faster than anything I've seen on the market. Big advantage for machining large structural parts, and also it's a big advantage for customers in terms of savings in process time.
And you talk about the size and weight of parts. You know, is the weight of the actual billet a limiting factor for Starrag?
Well, clearly the payload weight's one factor that will change, and it'll reduce in the course of the machining process quite significantly. So our machines are designed for the maximum payload, which represents the worst case, the mass that you've got to move. And we've now developed a system for the moving tables, the F models, that basically weighs the payload during the process, and then it enables the machine to adapt the dynamic behavior of the x-axis. So as the workpiece comes lighter, as you're cutting more material out, the axis becomes more dynamic. So it has a big positive effect on the process time. I suppose an example, an A350 billet weight just over 4 tons. After 2.5 hours of roughing, that weight's reduced by nearly 2 tons.
Now, it's quite interesting, actually, when you talk about the extra speed, but does it affect the accuracy of the machine tool?
Not detrimentally, but we have been working on accuracy, because as these monolithic components increase in size, we have to cope with inaccuracies due to the change in temperature, for example, in the machine shop. So we have an improved 6-axis space error compensation option for the attachable heads that gives us a sub 50 micron error in space accuracy. And we've developed new in-process measuring strategy to control and improve the overall accuracy on very long components. So the surface quality of the parts is outstanding, and manual reworks eliminated, accuracy is improved.
Yeah, I mean, I think, you know, when I look at sort of the extreme speeds, the removal rate of material as well, does Starrag machines actually suffer with any machine stability due to that?
Well, as you said earlier, you've seen how fast these things run, and it's a really interesting question, that, Mark. But from experience, we've developed a lot of tool assemblies that we know work, and they achieve extremely high cutting performance without sending chatter frequencies through the machines. But you're right, you need to deal with a lot of factors that can cause chatter and vibration. So the team in Mönchengladbach have developed a chatter monitoring system that's equipped with a dedicated HMI for the operator that shows him clearly, or her clearly, when the machine is running in an unstable process. This is linked to the NC program, and we can even video the process to show exactly where the chatter is detected. So the NC program can be modified to avoid the unstable conditions, and the stable operations are really important for parts right up to kind of 20 meters. You know, chatter and vibration is unacceptable.
Now, seeing some of these machines in the field, you know, I've seen the customers had to spend a lot of money to actually make special foundations in their floor. But I've also noticed that you now have machines that don't need that. They're actually floor mounted in your range. You know, why that change?
Yeah, all previous machines are still available with special foundations, as you say, but we listen to market demand. And one of the new products that I discussed earlier is the Ecospeed 1540. It's a new addition to the family with a 1.5 by 4 meter table, and it's floor mounted. So it was designed with cost in mind. It can be built and installed very competitively, short lead time, good investment level, and that's all passed on to the customer. Then we've got Starrag's new STC 800 and 1250X machines, which are also floor mounted, and they're specially designed using the same spindle technology as Ecospeed for very high performance of medium-sized structure components. So we believe these machines will really make our customers a lot of money.
And the type of customers that you're aiming at, you know, within the aerospace sector, why should these companies consider buying a Starrag, and what type of company should be talking to Starrag?
Well, anybody who's serious about cutting aluminium. So firstly, we ask customers to come and talk to us. Let us show them how we cut aluminium airframe components, show examples of cycle times. Any customer who wants to profitably produce aerostructure aluminium components from plate or forging should consider these machines. Existing customers tell us that these machines are the reasons they're winning the big contracts, and you don't have to be an OEM to afford one.
Now, I know I said this before. To wrap this up, it's another perfect example of Starrag's philosophy: engineering precisely what you value. Yet again, Lee, fantastic insight into aerostructure parts. Thanks for your time.